Howdy. This video will focus on what solving systems of linear equations by elimination is, and quite a few examples of elimination. So first, what is solving by elimination? Solving by elimination is basically a method of solving a system of linear equations very similar to solving for a variable of a simple equation. So we want to eliminate, let's say given x minus 6 equals 4. We want to eliminate the 6 on the left side so we can get x by itself. So first we have our equation, x minus 6 equals 4, and to eliminate the 6 we need to add 6 to both sides. So we do that, and so the 6's cancel, and we're left with x equals 10. This is very similar to what we'll be doing on our solving by elimination. So let's move on to our first example. It's quite a simple one. So given the system of linear equations solved by elimination. So we have our two equations, 2x plus y equals 9 and 3x minus y equals 16. On this side here, what can we eliminate really easy? We have a 2x and a 3x. If we add down, that's a 5x. We have a y and a negative y. If we add down, those cancel. So this is already set up for us. Let's go ahead and cancel these out. So what we're going to do is we're going to add down. So we're going to have 2x plus 3x, that's 5x. Plus y and a negative y, that cancels. So plus 0 equals 9 plus 16 is 25. So we're left with 5x equals 25. Finally, how do we get our x by itself? We have 5 times x. Opposite of multiplication is division. So we're going to divide both sides by 5. That leaves us with x equals 5 as our solution to this. But remember, there's one more step. We need to plug this 5 back into one of our equations to solve for y. So let's go ahead and bring this over here, plug in our 5, so we'll have 2 times 5 plus y equals 9. 2 times 5 is 10, so 10 plus y equals 9. We need to get y by itself, so we have 10 plus y. The opposite of addition is subtraction, so we're going to subtract 10 from both sides. And that leaves us with y equals negative 1. You can also plug your 5 into the second equation as well, and you're going to get the same thing. So, just to show y'all, let's plug in 5 to our second equation. So 3 times 5 minus y equals 16. 3 times 5 is 15, minus y equals 16. Subtract 15 from both sides to get y by itself. That leaves us with negative y equals 1. We have a negative 1 times y, and we need to get y by itself, so we need to divide by negative 1. And then, so the negatives cancel, we're left with y equals negative 1. So these are the same. Just proving that we can plug our x into either equation and get the same answer. So our official solution to this system of linear equations is 5, negative 1. Okay. Given the system of linear equations solved by elimination. Okay, so we have 2x minus y equals 9, and 3x plus 4y equals negative 14. Let's see, is this set up for us today? So 2x plus 3x, that's 5x. Negative y plus 4y is 3y, and then, okay, so it's not set up for us, but we can set it up this way. We already see that we have a positive and a minus here, and we have a 4 here. So we would need a 4 here in order for this to cancel, for our y's to cancel. So what would we do to get a 4 here? We would want to multiply everything on the first equation by 4. So over here, we're going to multiply the first row. So this is row 1. This is row 2. We're going to multiply the first row, so 4 times R1. And then that's going to transfer over here. We're going to have 4 times 2 is 8x minus 4 times 1 is 4y equals 9 times 4 is 36. And then bring our second equation down. So row 2. We're going to have 3x plus 4y equals negative 14. So now let's add down. Add down. So 8 plus 3, that is 11x. Negative 4 plus 4, that's 0. So plus 0 equals 36 minus 14, that is 22. Okay, so then we're left with 11x equals 22. We need to divide both sides by 11 because we have 11 times x. Opposite of multiplication is division, so divide both sides by 11. So x equals 2. Okay, so now, next step, we just need to put this x into one of our equations. I'm going to put it into the first equation. So we're going to have 2 times 2 minus y equals 9. 2 times 2 is 4, minus y equals 9. We have a positive 4 minus y. Opposite of addition is subtraction, so let's subtract 4 from both sides. So that leaves us with negative y equals 9 minus 4 is 5. Divide both sides by negative 11 to get rid of the negative. And so then y equals negative 5. So our official solution is put x and y in coordinate pair format, and we'll have 2, comma, negative 5 as our solution. Okay. Something even more difficult, but not so much. Given the system of the linear equations solved by elimination, we have 4x minus 3y equals 25, and negative 3x plus 8y equals 10. Okay, are any of these set up for us? So I have 4 minus 3, that's 1. 8 minus 3, that's 5. No. So what we need to do is figure out a way so that we can cancel the top and the bottom of one of the variables. So let's see. Pretty much 4 times 3, that's 12, right? And then 8 times 3 is a bit more difficult, that's 24. We want to focus on the smaller of the two, the numbers that are easier to multiply. So right here, what I want y'all to do is multiply row 2 by 4. So 4 times row 2. And row 1, multiply by 3. Okay? So we're going to have 3 times R1. So that will give us 3 times 4 is 12. X minus 3 times 3 is 9. Y equals 25. Next, 4 times R2. 4 times negative 3 is negative 12. X. 4 times 8 is 32y plus 32y equals 4 times 10 is 40. Okay, so now look right here. We have a positive 12 and a negative 12. Those can cancel. Awesome. So now we're going to add down. So 12 minus 12, that's 0. So 0 plus 32 minus 9, that's 23y. And then 4, and then add down, so 4, 5, 6, 65. Okay, I thought something was funky. Guess what I didn't do? I didn't multiply this 25 right there by 3. So what's 25 times 3? It's going to be 75. And 75 plus 40 is 115. Okay, that's a little better. So now let's bring everything down. We got 23y equals 115. So now we have 23 times y. We want to get y by itself, so what opposite of multiplication is division, so divide both sides by 23. And now we have, this cancels, and y equals 115 divided by 23 is 5. So y equals 5. So now let's plug this 5 back into one of our equations. I'm just going to choose the first one. So we're going to have 4x minus 3 times 5 equals 25. So then we'll have 4x minus 5 times 3 is 15 equals 25. We want x by itself, so we can solve for x. And we have minus 15, so opposite of subtraction is addition, so add 15 to both sides. So the 15's cancel. We'll have 4x equals 40. Divide x by 4. And x will equal 10. So our official solution to this system of equations is 10, 5. Okay. Given the system of linear equations solved by elimination. Okay, this is tricky. We have a fraction, but don't worry. We want to, again, have either the y's cancel or the x's cancel. So let's see. We already have a negative and a positive, and a positive. So we just need to multiply one of these by something to have the others cancel. So we have 13 divided by 2. We have a 13 here and a 13 here. So pretty much 13 divided by 2. If we multiply this 13 over 2 by 2, the 2's cancel, and we're left with 13 and 13. So 13 minus 13 is 0, right? So I want to multiply our row 2 by 2, and we're gonna leave our row 1 alone. So just bring row 1 over. So we'll have 12x minus 13y equals 2, and 2 times negative 6 is negative 12. And 2 times 13 over 2, the 2's will cancel, so we're left with plus 13y. 2 times negative 2, that's negative 4. Okay, so now we have our variables that will cancel. So let's go ahead and add down. So 12 minus 12, that's 0. Negative 13 plus 13, that's 0. And then 2 minus 4, that's negative 2. So bring everything down, we got 0 equals negative 2. Look what we have here. Does 0 equal negative 2? It does not. So if we have a solution that doesn't make sense, guess what? It is called inconsistent. And how many solutions does an inconsistent system have? None. So no solution. And remember that inconsistent is parallel lines. So they have same slope, different y-intercept. And remember, from now on, if you have a solution that does not make sense, so 0 equal 1, 0 equaling 5, that's not true. If you have an untrue statement, it is inconsistent. Okay. Next, given the system of linear equations solved by elimination. Okay, so here we have another, I think this is another tricky question example. We want to, remember, cancel out the y's or the x's by adding down. So this one's pretty simple. We have a 3 and we have a 1 here. So we can multiply the bottom by negative 3 because we want one of these symbols to be different. Okay, so what we're going to do, we're going to multiply the bottom. So we're going to multiply row 2 by negative 3. And we're going to leave row 1 alone. So let's bring everything over. We have 12x minus 3y equals 6. And negative 3 times 4 is negative 12x. Negative 3 times 1 is, negative 3 times negative 1 is positive 3y. And negative 3 times 2, that is, negative 6. Okay, so now we want to add down. So 12 minus 12, 0. Negative 3 plus 3, 0. 6 minus 6, 0. So then bring everything down. We have 0 equals 0. Alright. Check this out. If you have a true statement, 0 equals 0, 1 equals 1, 5 equals 5. If you have a true statement, then we have a dependent system of linear equations. And a dependent system has how many solutions? Infinite solutions. Okay, and remember, remember that dependent lines are the same exact line. So same slope, same y-intercept. Okay, so I believe that is all, folks. Please remember to take your notes. It is beneficial to every single one of y'all. And I will see y'all in class. Thanks for listening.